to say that. Yeah, okay. Now I even hear. You even hear me. Great. So today I'm going to talk about my background, which is more on research, but I want to connect that to development. And that's why I called the talk Bridging the Gap. Cutting edge research meets practical software testing. In my research community, I feel that things are going more or less in parallel to the development community, but I think there is a lot that we can learn from one another. And that's why I want to bring in some case studies that I and colleagues of mine have been working with and that are tightly connected to practical use. Mid-Sweden University, very good marketing or sell. It's simply a university in the middle of Sweden, right? So that's easy to understand, easy to remember. For you to see, compared to where we are today, this is Stockholm and Gothenburg. It's some 4 or 5 hours rides by train. I've been working there. I was shockingly realizing that some days back that I've been working there for 15 years, more or less full time. But yeah, so my involvement in research in AI and testing has been quite, time intensive. I've spent the last 5 years on software testing. Mostly before that, my background is in machine learning, evolutionary computation. But I've been working before my research work as a software engineer in Germany, originally from Germany. And I have some interest in social innovation as well. So I've been driving startups, failing a number of times. That's part of the story. And currently I'm the head of a small research group that we started in 2023, which is called Software Engineering Education. And in that group, we have 3 foci, and 2 of them I'm combining here today. One is on quality assurance of software, and they're specifically software testing, and the other one is on the gap between the industry demands and needs and what we educate at university. So to meet those 2 as good as we can. So that's what my talk is about. As a good researcher, I should of course have loads of mathematics and formulas and show my smartness. I want to promise you today that I will stick to this. So this is the only formula that you will see today. So no more formulas. Regarding the outline, I want to, as I said, highlight some showcases that I've been working with and colleagues of mine have been working with that are related to these major topics. One on regression testing, one on mutation testing, then testing AI in general, which is an area that we've been looking in more and more from a software engineering perspective. And then automated boundary value testing, which is a subject that has been difficult to realize, but that we have made some major progress forward. And then how we can how we can system test, end-to-end test our systems based on GUI tests. And there are specifically 2 examples. One of them based on large language models, a recent study that's been published there, which I think you will find quite interesting. The more I hear at conferences, and also yesterday in particular when it came to how we can interact with generative AI in our development environment, I feel that the statement is more and more getting true. The future's already here, it's just not evenly distributed. I think it's good and important to be up to date and learn about the latest things. And yeah, it's fascinating. We don't really know where we're going, but there is a lot to learn. And I'm learning a lot here, and I hope I can contribute to the learning. Regarding scope, so I don't want to come here and pretend that I'm better than everyone else here creating great production software every day. I'm just a researcher, so I will not show any live coding here in order to embarrass myself. But what I want to is to inspire you to read research work, reach out to researchers and see that this is actually not such a big step. There is a lot that's been published and been done that is practically applicable. And by that, we can hopefully build bridges because we have the same mission. We want to create software of great quality. That's our goal. When creating systems that are using AI, which is one of the main subjects that everyone talks about, it's important to have a distinction between these 2 ways of applying AI. And one of them has been highlighted in talks before, where we as developers are using tools that augment us, that make us better at what we're doing. So that's like kind of the right-hand side here. It's helping us to do our job better, to scale our job better, to do more things. Whereas on the other hand side, we have the automation part, which is more about removing the human out of the loop. Seemingly, we are in the research that we are doing, we're mostly interested in the augmentation part, to help people become better versions of themselves through tools and methods. The automation part is and has shown to be somewhat problematic in many situations, and there are many cases out there where the systems that have been deployed in reality are pretty crappy. And here is two cases that I want to highlight. There is one quite scary scary story about what happened in Rotterdam some years back, where social benefits are distributed to more than 30,000 people every year, and they've decided to create a system for that is combining traditional software methods, but in particular including machine learning. And what is scary with the system is that the more one realizes about how it works, and the more one was asking the public entities who are responsible for the system, the more one realized that the system is based on very faulty data and bad data. In particular, they've only been using 80 individuals in order to train that model, and there are strong biases towards, for instance, females. Being a female in their model is extremely negative in terms of receiving benefits, and not being able to speak the mother language is also a bad, really bad impact on your score, because they score you as an individual. Luckily, we have an EU Act now that disallows these kinds of systems, but it shows that there's a huge problem. We in Sweden have experienced a similar problem last autumn. For emergency calls. I don't know if any one of you picked this up. Have anyone seen this in the media? Yeah. So in short, it's about when you have to make an emergency call, you usually call a person and have a talk, and that person tries to calm you and try to assess the situation, do the best as they can. Now 1177, which is the entity that is responsible here for receiving calls, they said that they wanted to raise the accessibility of a service, so they created a chatbot. That chatbot was supposedly having 95% accuracy in the assessment, should be very good. So first of all, it's a chatbot, so that means that you're not calling anyone, but you're using your phone probably to choose certain alternatives, which might not be the most suitable situation if you're in a very, very stressful position. But on top of that, they did the study and found out that it's actually the diagnosis is pretty poor. So only in 1 out of 3 cases it would do a good job. And for instance, if you have a light headache and you wanted to get a diagnosis for a light headache, it would take you about 25 steps in their system to get to a diagnosis. And I think everyone here can acknowledge that if you have a light headache and you have to take 25 steps to get somewhere, then you get a really intense headache after that, right? So it's not really good. So whenever we're going from moving to including traditional software and then machine learning and AI in general, things become messy. And we have to make sure that the quality is good. And we realize that these systems have to be end-to-end tested. And there is this great pyramid that's been created by Martin Fowler, where you have, and you've seen many versions of that, you have the more unit-based tests furthest on the ground, and then you go up to integration test, system level, end-to-end tests. And the unit tests, they're fast and running, but they are and cheap, but they don't give so much confidence, whereas the higher you rise in your stack, the more expensive they get, and the more time it takes to execute these tests, to create them and maintain them. So this is a general challenge, and the challenge is not getting smaller when including AI. So when it comes to terminology, something that just to ensure there's no confusion, when we talk about test automation, usually there is 2 concepts that we would distinguish. One is on the test execution, and that's usually when you create your CI/CD pipelines and where you combine your services in a way so that you make sure when I have a commit, it should preferably end up in production as soon as possible, but it should go through all the necessary quality assurance steps. That's test execution, test automation, and then there is the test case generation, test automation. That's mostly what we talk about when we're looking at research, where we're interested in creating test cases without a human in the loop, which is a very difficult problem, and we've been struggling and wrestling with that for quite some time. Usually, software under test is the term for the system we're testing, so we say SUT. It's a common term for us. And you send something in, X in, and Y out. This is how we abstract it on a high level. And the test case generation problem leads to what is called the oracle problem, meaning that whenever you send something, an X, into a SUT, you want to know that the value that you get out is actually the expected value. And that's why the problem comes up that you need a human in the loop in most cases, because you don't have that oracle. You don't have somebody who can just tell you, this is the perfect answer to that question, because if you had that, then probably many of us wouldn't be sitting here. Some thoughts about, or just communicating how openness works these days in research. I think many have heard about arXiv when COVID hit. That is where all the medical researchers were updating their latest research. It's not peer-reviewed, but it's possible at least to share your results as soon as possible. Many researchers these days, me included, we are sending all our work before submitting it to a journal. We're sending it up to arXiv, so it's usually accessible and free. So it's not peer-reviewed at that point, but it's possible for you to get a lot of information, a lot of research work already at an early stage, the latest things, directly by going to arXiv.org. So the process that I'm using, amongst others, is that I upload a manuscript to arXiv, I send it into peer review. It will take months, maybe a year, until it will eventually end up being accepted. And if it is accepted, I will again upload it to arXiv. If not, some of the current publishers allow us to share it as what is called open access. Many of the publishers do that these days, so much of the stuff that I'm talking about, basically all, will be openly accessible for you. So it's there, it's out there, it's openly accessible, and on top of that, there is a resource that is a great resource to find interesting and relevant work. It's called Google Scholar. You might know it. All researchers individually share a copyright to their work as well. So even if it's published in some journal that you cannot access, you can definitely ask those researchers, send them a mail, and they will be happy to share their work with you. For the topics that I'm raising here, I try to cover these 4 aspects. So first, there should be a purpose or problem that I'm describing. There is usually a research article related to that, then at least one. Then there is a repository. This is also something that's become very common in our field, that we're not only doing research, but we make it reproducible, so that there will be GitHub repositories that you can download, you can play with, that contain usually the code, but also the experimental results. So you can do analysis, but also a reproduction. And on top of that, I try to have some boxes about implications. What could that practically mean for you as a software tester? Good, then let's start with regression testing. Who here in the room knows what regression testing is? About 2/3, maybe more. That's great. So it's basically a way of ensuring confidence in your tests, in the changes that you're making. So you make a change to your code base. There could be a commit with multiple files that are affected, and you want to know whether that's breaking the system, right? And then we call the method of assessing that the regression testing. Now, there are 3 different versions of regression testing that are usually separated into these categories, into 3 categories. And for that, what one usually does is to extract a lot of information about the tests, and one of them is coverage. So whether a test is covering a method or a function is usually expressed in what's called a binary metric. So here is a simple example. We have 3 test cases and we have 3 functions. Imagine that's a class with 3 methods, and these 3 test cases are then to a different extent covering those functions. So T1 is covering F1, T2 is covering F1 and F2. You get the idea. Now, three different ways of problems that you want to solve. One of them is the minimization, which means through time you will create new test cases, and it might be that some of the test cases become obsolete. You still run them all the time in your suite, and it's a bit messy and time consuming and so on. So what you want to do is permanently remove certain test cases from your test suite. And so that is one case. Say after some time you want to make sure that it's running faster, and you're removing test case 1 in this case. So just minimization. This is a permanent removal of test cases that are just bloating. Second one, selection. Now, we're not talking about removing something permanently, but given a certain change that you're making right now, you have a certain number of changes in your commit, you want to choose those tests that give you the best confidence for the time that you want to invest. So regression, whenever you do these optimizations, is always a trade-off. If you have enough time, if you have a small test set, test suite is not a problem. You can execute everything at once, no problem. But if you only do minor changes and you have a quite large test suite, you don't want to run something for 10 minutes just to check that your small change to a small unit in your code has an impact or has no impact. So what you do is you select a certain number of tests for that specific instance in time. The third one is prioritization. If you're doing smoke tests or tests where you're not quite sure, you might have been broken something. You want to make sure that you execute the tests in the right order, so that that it fails as fast as possible. Because then okay, it's not working. I don't have to wait 10 minutes. I can only wait 1 minute. So that is the more day-to-day business case that I'm drawing here. But there is also the case of doing regression tests maybe once a week, once a month for a whole system that is larger. And this is an example that I want to bring up now. I've been working with Huawei Cloud Computing in China, and they have among the biggest testing suites that you can imagine. And they have this question: how do we decide what tests to run when we have our commits? Because our because our test, let's focus on this table here, because our test suite is quite large. So you remember this this matrix that I showed you, 3 test cases. Now they have 11,000 test cases that they're running in one of the systems. The other one is a bit smaller, and they are covering 6,000 functions there, or 5,000 functions in the second system. And if they were to run this all at once, it would take them 3 months. So they really have to make a decision here, right? Whenever they do their regressions at night, we have 8 hours. So how do we delegate that time wisely, right? So we've been working with that, and without going into any details, if you want to geek out, you can look into the math and so on. Just on a high level, we've created a framework that can help them in the selection process, which of course considers only those functions that have been affected and the tests that have been affected, and it's including different optimization criteria. This is published on GitHub. The tool, it gives them greater confidence, large savings, and an efficiency boost, because the developers can actually go on working and don't have to wait 3 months until the results come out. Of course, they had a method before, but that method wasn't as efficient. So you can find it here on GitHub if you want to have a look. The conference is called Jfokus. It's written in Julia, so I hope that still qualifies. Jfokus. Good, and so this can also be customized. So if you have different metrics like function coverage on different levels, module coverage, you have, you name it. You can include all kinds of metrics that you're extracting from your test suite. The more, the better. So this is one case study where we would make a difference. It's just that not everyone has these kinds of systems. So I'm understanding that not everyone sees the need in this kind of research, but it's practical and you can download it. Good. So yeah, basically just to highlight what's happening. So the existing methods, they are more heuristic methods that that can include multiple criteria, but they at some point they converge, meaning that if you see the green one and the purple one there, this is seconds, by the way. So some 5 minutes. After 5 minutes, you see that the method that we've included is not even converging entirely. So you can, if you run for 10 minutes, probably even better test selection suites that are selected. And you might be wondering why there is so many different ones. It's because we're comparing open source variants to more. We're including into this framework what is called integer solvers. and they are different versions. Some of them are freely available, some not. So we're comparing open source to commercial ones, and we're seeing that for our use case, the open source ones are totally fine. So one can use all of this using entirely only open source and do get an extreme boost in performance. Good. So that was regression testing. So test closed. Then mutation testing. Who here knows what mutation testing is? Okay, that's fewer. That's maybe 1/3, maybe a bit more. There is a great talk. Actually, I digged it up in 2016. You can find it through going to that using that QR code, which is giving more the basics and explaining how you can do it in practice in Java using a framework called PyTest. Very good talk. I will not go into detail about that, but basically what it's about is another way of assessing the quality of your test suite. It basically reveals blind spots in your test suite by what is called killing mutants. So what do? In practice, you have your code base and you have a test suite. And what you do is you go into your code base and you do certain what's called mutations. You remove something, you remove a line, you instead of having an end sign, you in a logical expression, you make it an or, and just run it then. You run it through the test suite. And so obviously you're creating a mess in your code. And this mess should be reflected in the test outcome, right? So if you're creating a mess, there should be failing tests. So what you usually hope for is when you run your test suite that you have passing tests. Now we're looking for failing tests. So you have a test suite, and then whenever it finds a bug, going red, it kills a mutant, and that's good, because then we can dig and see what this change actually implies for your code, and whether it's breaking something that you don't cover with the test case. So if you have these situations, you might want to include new test cases. To give you an example, so this is PyTest, this is the tool that I mentioned. Here's a Java example. It's to transfer money from one account to another account. And in order to do this, you have to withdraw money and you have to deposit money. A very simple function. I see probably some of you are saying, you have to do this atomically, there must be synchronized or something. But that's not what we're talking about here now. It's not important, but I mean, it's point taken in that case. But one mutant of that would be to remove. And here we would just remove the withdrawal. So if we were running this in the test suite and this would pass, that's a bad sign, right? Something's really bad. Another alternative would be the substitute. You're using a method that is similar, that has the same signature but a different name in the same class. So for instance here, instead of having the from withdraw, you choose from deposit because it has the same signature except for the name. And this should clearly also result in a failure, right? Failing test. If it doesn't, you have to change your tests to ensure that it's doing it, So this is a nice tool. It has some downsides though, and that is that, well, how do we choose operators? What are the operators? I showed substitution and delete, but there are hundreds of potential operators, which are good ones. And that's why we have research for, right? So there are researchers, a former colleague of mine, Gregory, in Chalmers. He was working on, identifying how are the operators and their doings, the syntactical doings, coupled to a semantical impact. And he found out that there is actually more or less 10% of those operators that are out there that have this connection, this semantic syntactic connection. Some of them are listed here now, and I mentioned here this EMM, for instance, is the one that I mentioned now, where you have the substitute. In practice, that means mutation testing is quite expensive because you have to make a change to your code and then run it through the whole test suite, right? And then you do that multiple times. So when I'm running this even in test projects, it will be hundreds, if not thousands, of different test suite executions. Very expensive. So if you know what the operators are that actually are relevant, that connect syntactical changes to semantical changes, then you can reduce that. And here it shows that you can reduce it to 10% of that time. So if you otherwise have to run 1,000 mutants, you can run 100 mutants. And you do that by reading up the research that was recently published last year. That was recently published by Gregory, or listening to me here telling you about it, in order to understand how to navigate these tools that are out there the best way. So there is a lot of knowledge there that can help us be more efficient practically. I also want to throw in test types and terminology as a thing that should be discussed, I think, because is there a common is there common terminology we're using? Not always, and so we have to really make sure that we establish a good common terminology. IEEE is a standard body, and they've tried to define what a unit is, a unit test, integration test, very technical. I don't even know if this seems somewhat contradictory. I'm trying to follow this. Test of an individual hardware or software unit, okay, I can follow that, or groups of related units. Okay, and that's a unit test then. So tests of groups of related units. They lost me, you know. It's like I'm not with you anymore. Sorry, that's not a unit for me. And so they did some research on this, and they did a really good work of connecting the meaning of what they ascribe a unit test and an integration test, and see what the potential flaws could be. See whether the flaws in existing errors that have been identified in projects formally, that have been fixed by pull requests, how they map to either unit tests or integration tests. And they saw that you cannot even say that what is a unit, what is an integration test based on the level of what they are assigned to in practice. So their practical suggestion was, why don't we call units a component of a complex system, and unit tests that they assess correctness within that unit only? That's a kind of simple way of putting it. Integration tests require components to work together. You know, like this is just one way of you know, getting an insight of these difficulties of defining things, reading a paper, and you know, hearing somebody else's discussion and empirical evaluation of how we should think instead. You know, it's like challenging the status quo. I think that's useful, in particular when it comes to definitions that are so lousy. So then we have production data. This is an example. I wanted to give an example from Stockholm because we're in Stockholm, and there are great people here working at KTH, the Royal Institute. And Deepika, she's a PhD student there. She's created a tool that is extracting production data to create tests. And I find that intriguing because you have your test suite, and it's having some coverage of your system. But how does that reflect the actual uses of that system? When you look into production data, you can actually see what are the traces of use in practice, and you can extract. Of course, you have to think of anonymization and so on, but you can extract test cases based on that. That's what they're doing here with the tool, and then you can look into how that covers different aspects of the system under test, and by that you can enrich your test suite. At least you enrich your knowledge, but probably you also enrich your test suite because it automatically creates unit tests and tests which you can add. Yeah, that was mutation testing. And now, yeah, testing AI. So is that different? Is that different to testing regular systems? Anyone here having experience with testing AI? One hand up. Yeah, easy. Detecting changes in data drift, yeah. It's more involved, right? Yeah, and you might recall, some of us might recall this. Of course, this is before my time, but we've been going through 2 AI winters. You know, that was somewhere in the 60s, 70s, and then in the 80s, 90s. The reason for that, like on a high level, was too high expectations on AI. So that was one of the problems that we were meeting. And now we don't know, are we facing a third one? Right now everyone is very bullish. Yeah? Everyone's talking about AI. We don't know about that. But just for the sake of this talk, generally we see that machine learning is a part of AI. It's an important part of AI that has been growing in attention a lot. And now we have this sub area, which is generative AI, which everyone is talking about now, ChatGPT and DALL-E and so on. And the focus there is rather on the what instead of the how. Just quickly going through this example, I'm sure you've seen this a million times, classifying whether something is a muffin or is a dog. You label these and you say, oh, this is a muffin, this is a dog, and so on. You train a model. send them into this algorithm, this number crunching algorithm, and what it gets out is this model that you can then ask, is this a muffin, and it will give you, or what is this, and it tells you it's a muffin, and it gives you some confidence to that. So that's in principle how machine learning works. Similar to regression problems, it's just not exactly the same. But there is this question of whether, when we're testing AI and when we're testing regular systems, is there what is the actual difference? Is there a difference? Should we see a difference? And seemingly there is a difference. So we could talk about what could be termed a duality. We have two ways of seeing upon the same thing, because it's two softwares, but they're working in very different ways, but they're solving similar problems. So we can we can write a statement. We can call it the duality of human developed and learned software. And we can say that software is either developed by humans or automatically learned by machines. So there's like two different starting points. And this is key in considering how they are to be tested. So that makes a major difference in how we actually do our testing procedures. What we are trying to see then is that, look, are there commonalities? So here on the right-hand side, where you have the software artifacts, you have a learn component and you have a program component. The difference there can be seen in the process, but not so much the result, because from a high level, you see that both of them have inputs and they both have outputs. There should be ways for us to test them in similar ways. But the approach is very different. In traditional software, you have people who sit down, they write their if-else clauses. And of course, these days now we get a lot of support from our small assistants. But in data science, the process looks more like this. You have a configuration code, which of course is created by humans. And you have your training data, and those together then make for this learned component. So does this really make a difference in how we're supposed to work with testing? If we consider it as a black box, potentially not. That's what much of my research is about. If we consider it as a black box, then there are ways to test things similarly, but there are also differences. So ML solves more probabilistic or fuzzy problems, like the assessment of visual assessment of a dog versus a muffin, for instance. It's a very different assessment than how you would do the coding if you were to create it with if-else statements. And so one question is, isn't it that we do automation here and we're solving the same problems? Isn't the chatbot that we're creating, the example that I gave you before, solving a problem that we had before? We just want to take the human out of the loop. So we should be able to solve it in similar ways that we did before, Just the problem is that there we didn't have a computer program that solved that specific problem. We are trying to automate a human away. And human assessment, human quality output assessment is very different to how we do software testing assessment. So that's where a huge difference is. We're not always removing an existing software by AI, but we're removing humans by AI. So that makes a difference. And there are three dualities that have been discussed by Paolo Tonella, who's a professor in the subject area, at a keynote, and I bring them up here briefly. Aspects that are clearly different. Coverage. When we talk about coverage in code, you have your function coverage or you have your line coverage, depending on how granular you want it. But we can assess that. But in these machine learning models, let's take as an example neural networks, because they are behind all generative AI. You cannot really compare. When we do the assessment of a function and it's test a function in isolation, we cannot do the same in a neural network. Because in a neural network, you put something in the very beginning in and you get something out, and that's the things that you can comprehend. But everything that happens in between doesn't make any sense. So you cannot take out like a part and then test it because you don't know what to expect. On top of that, you have activations. That means that you have just a signal going through, something between 0 and 1, and that's between all these layers. So it's very messy. So here clearly we cannot use white box testing as we do in our traditional software testing in neural networks. So ML, if you want to learn about ML testing, you have to do end-to-end testing. And what you need is to learn about the metrics, how you do precision recall. You need an experimental approach to it. You have to really try it in different situations with different tests, test cases, and so forth. You cannot just isolate different functional components. A question? If you can see the optimizer, sorry, what did you mean? Yes. So that is an experimental approach, but you cannot look into it here and make sense of what's going on. That's basically exactly. So what the point is, you need an end-to-end approach. You have to look. You have to look at the whole system in order to make an assessment. You cannot make any functional assessment of just a part of it. It's been considered, but there is no. You don't really get a sense of it. There is no logic because when you think about the idea with the dog, for instance, you send in a picture of a dog that is vectorized, then you get a lot of numbers. It's just numbers at some point, and then there are activation patterns. So it doesn't help you. There is no comprehension involved in that. The network is determined. Usually, it's deterministic, but maybe we have to go. We could talk about that a bit later on as well. So there is a huge difference, at least, in isolating testing in units and how we do it in traditional software compared to how you test machine learning. And then, what is a bug? Determinism was just mentioned. Whenever you send in the same x, you get the same y out. So that would mean determinism. We don't always have that in traditional systems either. We have non-determinism due to, for instance, flaky tests, hardware errors, and so on. But bugs take very different form. So you have wrong classifications, but an individual classification you cannot say much about the system as a whole. You have to do it multiple times with a number of instances in order to get a statistical error. So you have these different metrics that I already mentioned before. Whereas in our traditional software, where it's oftentimes and preferably deterministic, then what you get is a failing test. Then you can handle that. You can go back into the code, you can identify where it is, and then you can work on that. If you want to learn about how to do more structural tests and ML models, then you can learn about a concept that's called cross-validation. That's very good to learn about. But it's time-consuming and it's end-to-end. So that's something to take away from this. It's a different approach. You cannot isolate units. And another one, input validity. You have very little control about what is accepted as inputs for an AI system when you want to test it. So if you have pictures, for instance, there is nothing that limits you from sending in an elephant or a banana, whatever, into the system. You have to do some filtering. Either you do some pre-filtering or post-filtering. This is also a research project that we work on. A practical aspect that you really should think about is the control of your input ranges when you test your regular software. That's something that we learned about in our studies, that you have a lot of power by defining the input ranges and by limiting them as much as you can. You have a possibility to reduce the risk of failures onwards. Now, I'll give you examples of that. So we're getting into automated boundary value testing, which is my area of research. You might have heard about the Heartbleed vulnerability in OpenSSL, which was basically a buffer overrun. And then there was in 2019, there was this pseudo error, which actually escalated whenever you were entering -1 as your ID, as your user ID, you would get admin rights. It's a very simple way of getting admin rights. So, and that is just a boundary error, right? So how can we find these boundaries that are seemingly, it should be easy to spot, but since software is so vast, it's not easy to do that manually, right? So it's at the boundaries where interesting things happen. And regarding the software, the automated boundary value testing, when we're testing our software, we don't always want to have repeated test cases that are very similar to one another, that are common. We are more interested in having test cases that are on the boundaries. You probably know the trolley problems in AI. Should we drive over that lady, or should we crush down the canyon? It's like these strange situations that we as developers shouldn't take. Somebody should tell us how we should develop them. At some point, there is a boundary, right, where the decision is changing. So we want to understand these boundaries. That's where the interesting things happen. One app or program that we've been mining from the internet, different versions of, is the BMI calculation. This is really just to give you an impression of how body mass index can trigger a thinking process here. You have two parameters. You have the height and you have the weight, and they're both as integers put into the system. And what we're doing some number crunching. We have a method to do this quite efficiently, and we get boundaries. So we're mining boundaries, and we're also filtering them so that we don't get like too many, but like a reasonable amount. And we get some boundaries that are somewhat reasonable. So there is one if you're well, it's a small people here, right? But just bear with me. So 108 centimeters long, and then you're 26 in kilo, your normal weight, and then you're overweight with 27. Okay, that's probably a reasonable boundary. Then if we're looking at some other boundaries, we're a bit more surprised, right? Like if you're 1 centimeter long and you weigh 0, then you're underweight. And if you're 1 centimeter long and you weigh 1, then you're severely obese. So this boundary shouldn't exist, right? It's like seemingly unmeaningful to have this kind of boundary. And there are different similar examples. So how can this problem be resolved? How can we end up not having these situations? Here is another example. Julia is the language that I was talking about. In Julia, you can, and this is probably similar in Java that you can trigger these kinds of situations. We just tried Julia. There is a type min for a type. Int 8 has a minus 128, and then 127 for type max. And then there are more structured types. This is a constructor for date, creating a date for 2020 here, and this is how it works. Then you can also use the type max for a date. This is all the core library of Julia. And okay, you get a really large date. Probably you will not use it in many practical situations, but if you do some astrological calculations, it might be relevant for you. Good. So you can also use these handles in order to assess, whether this date has how many months a date has, and so forth. And now I can instantiate that, right? So I got this as a maximum. I instantiate that works. Now talking about boundaries, I would be curious to know what happens behind a boundary, right? So what if I go 1 plus? And I was doing that. Oh, I was doing that, and it works. So it's like accepted. It's like the maximum value, but it's accepted plus 1. Strange. What if I add a year? So I'm adding a year. It's still a valid output, so this is not an error message, and I get this. And just to verify that I'm not completely crazy, I'm asking, so what is the month of this? Yeah, that's a weird one. That was an unexpected month, right? I don't know, is that December? No. But so if I, though, use the 31st of November, which is never any year date, there I'm getting an argument error. This seems somewhat inconsistent, right? We would like to have something more consistent. How could this potentially be solved? Well, limiting input ranges, making sure that such a date can never be instantiated, because then you would receive an error response, and be consistent. Now, Java, I'm hearing, I know that there are enums. You can do that to some extent. Probably you wouldn't use an enum in order to define the year here, because that would be a very, very big enum. But you can use that for the month or for the day. And there are also efficient ways of doing that soon, as I understand, the inline classes for Valhalla. I have, which is an extension of primitive types. I've tried to find the latest update on the syntax. I failed. I couldn't find anything because it seems like it's still in the making. But there at least you have a way to efficiently create these ranges, even larger ranges that you could cover with enums. And now to the final, what I think possibly most interesting case is the GUI testing, where you can do end-to-end tests. And this can be true for both AI systems, but also for traditional software. Here we're looking more into traditional software. GUI testing has been going through anyone here using GUI tests? Quite many. That's like half of the room. Nice. The traditional way of doing GUI tests is you do your recordings, you start your tool, you do a recording, and it like recalls on where you were pressing what. It's recording like every tap you're doing and so on. That's of course breaking things easily if you move a button and so that didn't work too well. Then the second generation, one could say, were those tools like Selenium, where you would have a driver that is working in the background, often headless, where you can trigger certain sequences. But still, you're saying exactly in what order things are happening, right? So you explain how. Now the third generation is what I will focus on. Two ways of doing that in the third generation is that you more on a high level describe what you want to happen. And one way, so this is like a lot more declarative way of doing things. We see this movement in programming also to reactive programming, and so functional programming, we're going more declarative because we don't want to explain all the details. We want the system to be smart enough to help us. Examples of these, I mentioned Selenium. When it comes to the third point here, actually LLMs can be employed for this. And there is a tool called Scout, an open source tool that friends of mine or colleagues of mine in Blekinge University in Karlskrona are working on. And that's the one that I bring up here, third generation, the industrial applicability of augmented testing. And in here you can see a small, very brief demo of how it's working. There are basically it's an augmentation. You have your web page, so this is just a regular web page with some extra buttons that are in your browser. And what you're doing is you get tips on existing traces that have already been used that are colored. And there are other fields. There are 3 colors that are being used. One for showing the where you want to create a new case. One as a suggestion for input that you can input according to some kind of smartness that is in the background, for instance, a name or an email address. So this is all like fired up through AI in the background. And it's helping you to create test traces that are covering different paths of your GUI. Now, this is still, though, manually driven. So you as a human are using this. You're driving this practically yourself. These can be extracted then to unit tests and Selenium so that you can run them. So you don't have to code it at least anymore. You can just go into your graphical interface, click, and then you get the unit tests. Probably not rocket science, but that's at least a nice feature. Yes, and what they did was they were comparing this to other tools. Anyone using Selenium here? Many Selenium users. Seemingly much faster to create because you're just clicking your way to code, whereas in Selenium you have to do the coding. So yeah, maybe now with ChatGPT it's I don't know. I couldn't say if it's faster than, but they did this some year back, I think. So yes, now the final one on using large language models. We heard in previous talks about how we can directly use large language models in our IDE to communicate as a human and even get a simplified interfacing with copy and paste using a diff and so into existing code. Now, for GUI testing, we can use similar technique. We can use LangChain4j, like they explained yesterday, and we can practically have LLMs communicate with one another and investigate GUIs for us. So we don't even have to be in the loop anymore. And this is what colleagues of mine have been doing in a work that has just been accepted for a conference this year, and that was submitted to arXiv in November last year. So very recent work. You remember the cost of having UI tests, very expensive. Now, here we set up LLMs in a collaboration model, 4 actually, that have different roles in the communication. They together, just as experts would, if they look at a program, in this case an Android program, they are looking at a interface. They're getting the background description, the widgets and so on of that interface as a description in code. They are seeing the interface, and then they have a dialogue about this. You know, how are we going to solve this? And they have one task, and this is on a high level in order to solve different kinds of situations. That is, how do we address and find as many activities as we can? Android applications are separated into activities. So web pages, you would probably have as many homepage different URLs as you can. That would be the objective. And LangChain4j is one tool that you could use for that. I'm not having the time to go into detail here, but there is a planner who is a GPT-4, like a very smart guy, you know, who can then delegate some of the work to the actor, who was the drunken junior developer, as we learned yesterday in one of the talks, is a GPT 3.5, so not as sophisticated. But they all have different roles, communicate, and this is how the protocol could look like. So not only can you extract then from this the use cases, but you get also the execution script. So you can get both out of that, and you don't need human involvement in this. It's completely transparent. You can get the output out of that. Use case here, practically. You have this app, Quick Chat. They are looking at this. What do we do about? Oh, let's create a user. We cannot log in. Let's create a user. That's the first thing they do. They create a user. Then what they do in the next step, they decide, okay, let's log out. Let's create a new user, because somehow a chatting app requires multiple users. Now, no person involved in this. They try to create a new user. They see there is a limit in how many tokens you can enter or characters you can enter. They get this as a feedback. They get back, talk about it, change the email address, use another email address, and then log in, create this account. Yeah, and now they come to the point where they say, oh, we want to add that other person as a friend, because that's in the system. That's kind of much, that and you get the script and the use case for that. So I skipped the part of prompting patterns. You will find this also on the slides that I will soon upload. But it's really important to know how to interact with these ChatGPT and so on, in order to effectively develop, and test. And there is the recipe pattern that I exemplify here. But back to the gap then. So we're always looking for collaboration partners for research projects, because it's always useful to create direct value, but also to understand, create knowledge for us and share knowledge back, in order to solve existing problems that you're having out there. That can be done through thesis work, can be done through guest lectures both ways, and research projects. This is not only for me or for the people that I work with, because I'm regionally somewhere else probably than you are, many of you at least. So get in touch with researchers that are software engineering researchers. I think there can be a lot of value created through us together. So yeah, that's what I had today. Thank you.